Learn something new every day for everyone. Have something you want to learn? Submit yours at lumolab.org.
What if your primary evaluation metric is lying to you? Researchers at Google DeepMind have uncovered a mathematical paradox. A large language model can score excellent on perplexity, the gold standard metric, while spewing obvious errors. This isn't a glitch. It is a fundamental mathematical guarantee.
Perplexity measures surprise. It calculates how uncertain a model is about the next token, using the exponential of the average negative log probability. Lower is better. A score of 1 implies perfect certainty. It is cheap to compute and easy to compare, which is why it drives the development of almost every modern LLM.
Here's the trap. Perplexity compresses confidence and correctness into a single number. A model can game the score by being hyper-confident on easy tokens while failing the hard ones. A confident but wrong model can actually outscore a model that is hesitant but factually correct. To prove this, they stripped away the language. The test, a bitstring copy task. Input a binary sequence like 0101, output the exact same sequence. The vocabulary is minimal. It looks trivial. But this simple constraint exposes a fatal flaw in how transformers handle probability.
Leveraging transformer continuity, they proved a stunning result. Take a long sequence, alpha, which the model copies perfectly. There must exist a neighbor sequence, beta, differing by just 1 bit. The model gets beta wrong. But because the sequence is long and confidence is high elsewhere, their perplexity scores become mathematically indistinguishable.
Here is the formal proof. For any confidence level 1 minus gamma, as the sequence length n grows, the difference in perplexity between the right answer and the wrong answer vanishes. The failure becomes invisible to the metric. Worse, the gradient signal shrinks to 0. The model isn't just wrong, it physically cannot learn to correct the mistake. This isn't just theory. They tested it on Gemma 3, a 4 billion parameter model. The results perfectly tracked the math. As the input sequence got longer, the perplexity gap between correct and incorrect outputs collapsed to near 0. The model continued to fail the copy task, but the perplexity metric signaled that everything was fine. The team mapped this using Iso-perplexity curves, lines where different accuracy and confidence levels yield the same score. They identified unfavorable regions below the curve. Here, a model with higher accuracy is penalized simply because it is less confident. To maintain a good perplexity score, extraordinary confidence effectively becomes a substitute for actual accuracy.
Does this happen in practice? They trained models on a parity task, predicting the XOR sum. In distribution, it worked. Perplexity correlated with accuracy with a Pearson coefficient of -0.94. But out of distribution, the correlation inverted. The model with the highest actual accuracy ended up with one of the worst perplexity scores.
This is the mechanism of failure, distribution shift. When models face unfamiliar data, they often remain confident but become wrong. Since perplexity averages over all tokens, it cannot distinguish between confident and right versus confident and wrong. High confidence, usually a sign of mastery, transforms into a mathematical liability that masks errors. The implications are critical for production. Whether you are fine-tuning for code generation or evaluating long context reasoning, perplexity is unreliable. A model might top the leaderboard while hallucinating on the specific, rare edge cases that actually break your application. The metric we trust the most has a structural blind spot. There is no single replacement metric yet, but you have tools. Monitor entropy, plot the iso-perplexity curves, and treat out-of-distribution scores with extreme skepticism. Perplexity is a useful proxy, but never forget what it actually calculates. It measures how surprised the model is, not whether the model is right. Thanks for watching, and keep learning.